Is this thing working? Yes, it is. Hello, everyone. Thank you for coming. Right, let's cut to the chase. Who here wanted Dave Farley? Only me. No, that's right. Don't lie to me. Okay, so Dave is unwell. He'll get better soon. He sends his apologies. And I am breaking our golden rule. I'm an organiser speaking at my own conference, so I'm sorry about that. But I do have something interesting to share with you, and that's how you can give yourself a better chance of adopting continuous delivery. I've got a bit of theory for you and a case study that's pretty impressive. Wouter is here. Wouter and I spoke about this at Lean Agile Scotland last October, and Jez was doing a keynote afterwards. And Wouter would tell you how excited I was to share this news that I had, this new thing I had with Jez, and I did my normal thing. I lay in wait for him, not at the airport, but I lay in wait at the conference, and I pounced on him, and as normal he was jet lagged and didn't put up much resistance. And I talked to him through the kind of stuff we've been doing and the scale we'd done it at, and he was really impressed and was like, you should do a talk on that. And I was like, I'll do that and I'll write a book. So who here thinks that continuous delivery is difficult? Okay, the rest of you are in denial, or you are liars, okay? Continuous delivery is very difficult, and I'm going to show you some measurement techniques that you can use tomorrow with very little implementation effort to find out for yourselves how you can better guide your own adoption of continuous delivery. So if you don't know me, I'm a continuous delivery consultant and a trainer. I do continuous delivery training courses for managers and practitioners, and I'm writing a book at the moment on measuring continuous delivery. It's on LeanPub. I'll give you a URL at the end for a discount on it. I'm also the co-author of a book called Build Quality, which is also on LeanPub, and some of the other writers of it here, Rachel Laycock contributed to it, Matthew did, Chris O'Dell, and I'm probably forgetting some other people. So I'm not going to tell you what continuous delivery is, because this is not the conference to do that. What I will ask is, what does it actually mean to be doing continuous delivery? People get a bit vague about it. I had a drink with Dave a while ago and asked him, what does it mean to you? And he kind of looked at me really carefully and said, you know, I think it's when you're able to deploy whenever you want, which wasn't quite what I wanted, but it was what I thought you'd say. So for me, an organisation is in a state of continuous delivery when the speed and stability of your IT delivery can satisfy business demand. When you do not have that, when you are too slow or not stable enough to match business demand, you are in a state of discontinuous delivery. That is a thing that I made up. I'm trademarking it. It is mine. I literally went on dictionary.com and looked up antonyms. Why is continuous delivery so difficult? Well, on the face of it, it's the amount of technology and organisational changes involved, and that's demonstrated by the size of the book. The book just isn't just large because it was Conway's Law and two different people in two different continents were both writing the same thing in slightly different ways. One person laughed at that, which is good. That shows he's also read the book. But of course, the worst possible thing is one person laughing at a joke. That suggests it has no commercial possibilities. Okay, so here is a list of technology changes from the book and some others that I cooked up at my dining room table. Now, all of these changes you'll be familiar with. All of these changes are hard. All of these changes are very valuable because they're all in their own part an enabler of continuous delivery. So let's pick out automated database migrations. How many people here can honestly tell me that their database migrations are fully automated? I'm suspicious about that. Okay, one person has a confident arm up. Okay, one person there. Okay, so ask yourself, please, how hard would it be to get that in place? And I don't mean the people side, I mean the implementation, the technology part of it. Even if you use some of the tools around now, like Axel Fontaine's DB Deploy is very good, it's very challenging to get that in place. But when you do, it will help stability and speed, okay? But all of these will do that. So which should you do first? Which should you do next? Which will work, which won't for you? On top of that, you have to think about the tools that are involved. There's a smorgasbord of tools available now. We have some great sponsors here today. If you haven't been able to see them, I encourage you to. And the good news with tools, I hope they're not listening, I'm probably safe back here. The good news is it doesn't matter too much which particular tools you use, as long as you avoid the really, really bad ones, okay? So it doesn't matter if you're using Docker or Kubernetes or Solaris zones, just don't use WebSphere. All right, so one person here who's dealt with IBM before other than me, okay. No business from IBM in the future. All right, good. So I thought of these organisational changes. These are hinted at in the book and the literature of continuous delivery over the last 7 to 10 years. Now, all of these are more valuable than the technology changes, and all of these are more time-consuming, and all of them are more challenging. So again, let's pick out one. Everybody doing on-call. I think Dan did this earlier in his talk, but everyone in a team doing on-call is very rare. Okay, and I don't just mean developers and ops. I get tired of people talking about that as like a special set of people. I'm talking about business analysts, product owners, testers, user experience people, user researchers, everyone actually having the potential to be called at 4 in the morning about something and to care about it. Okay? That is very, very, very hard to get in place. But when you do, that's going to make a big difference to the stability of your IT services. Now, it's not these technology and organisational changes that actually make continuous delivery difficult. It's the application of them to the unique circumstances and constraints of your organisation. Okay? Your organisation is a complex adaptive system in which every individual, including the tall, quirkily handsome continuous delivery consultant, has a limited amount of information, and the cause and effect of any event, such as said consultant pushing buttons he wasn't supposed to, the cause and effect can only be established in retrospect. Okay? So bearing that in mind, if you just blindly run around doing technology stuff and organisational stuff, some will work and some will not. And as people here will know, if you try to adopt continuous delivery, if you make a bad enough mistake, it will end, okay? Because you have to probably be perfect all the way through, okay? Or at least good enough that you have some goodwill, okay? If for when you inevitably make mistakes. So, the question then is, what gives us the best chance to adopt continuous delivery? And the answer is, we need to continuously improve the stability and speed of our IT release process until it can satisfy business demand. Okay? That's when you move from discontinuous delivery to continuous delivery. Now that sounds very easy. You should do it in an incremental, iterative fashion, of course. But how can we do that? So the best way to do that is with the Improvement Kata, which I'm sure people here are familiar with. It's mentioned at great length in the Lean Enterprise book. The Improvement Kata is by a guy called Mike Rover, following years of study of the Toyota production system. In the Improvement Kata, we put structures around our existing ways of working in order to facilitate incremental and iterative changes. So what we do is repeated cycles of a 4-step process. First of all, we need to create a direction, so we outline the stability and speed that we need in order to succeed. So one of the sponsored Lightning talks mentioned a vision. They talked about their speed that they were looking for. Anyone remember what that was? No, it wasn't Spotify. Spotify aren't here today. Stop copying Spotify. But they do begin with S. Thank you. What did Skyscanner say? 10,000 deploys a day. Okay? So that's their vision of success for speed. They didn't talk about stability. They should have. If you get 10,000 deploys a day and a high failure rate, then things are going to stop pretty quickly, right? Perhaps they have, I don't know. Okay, so after we have our vision of success, we create an analysis of how far we've come. We understand the distance we've travelled so far, and from that we gain an understanding of how far we still have to go. We don't know the exact path, but we have the direction of travel in front of us. After that, we create a target condition. We establish an improvement milestone that we want to work towards next, a small leap forward, and that might have some stability or speed success criteria. And then we attach a time horizon to that, and then we work towards until we meet one of those. We use the Deming cycle, the plan, do, check, act cycle to run experiments. That's where we try technology and organisational changes out. Okay, so that's lovely, but then our question becomes, how do we know if we are actually improving? How do we know if we are moving towards our vision of success? How do we know if we should work on stability or speed next? How do we know if particular technology or organisational changes are actually having a positive impact, a negligible impact, or a negative impact? And the obvious answer to that then is that you need to measure the stability and speed of your IT release process in order to reduce uncertainty and to make better decisions. So luckily for us, Jez Humble, Nicole Forsgren and friends have laid the groundwork for us on measuring IT stability and speed. How many people were here for Jez Humble's keynote last year? Lots of people. I wasn't. I was in hospital trying to persuade a baby to be born. I was very reluctant. So obviously I watched it afterwards, and I went back to where I was working at the time, and obviously the feedback was really positive because Jez is a great speaker, obviously. But the people I was working with were like, oh, yeah, we're kind of doing that already, aren't we? Which was kind of a sign that we were heading in the right direction ourselves. But I'll come to that in a moment. So Jez and Nicole, over a number of years, have done the annual State of DevOps report. So that's a massive worldwide survey of thousands of practitioners. And they found out all kinds of nice things, such as organizations that deploy very frequently to production are twice as likely to exceed market share, productivity, profitability expectations. They've also had some peer-reviewed academic research that shows that as you improve throughput, stability improves in kind and vice versa. There's a really delicious virtuous circle there waiting for you. Unfortunately, for years, large consultancies have told you that you have to choose between features and stability. They have been lying to you because they want your money. I'm sorry to be the ones to tell you that for the first time. I know that no one else was aware of that. Okay, so how is this pertinent to us? Well, Nicole, Jez and friends have always used the same 4 measures of stability and speed, and they are of enormous interest. So they've quantified stability using change failure rate, how often changes go wrong, and failure recovery time, how long it takes you to recover from a failed change. And they've quantified throughput using lead time, how long it takes to make a change, and frequency, how often you make changes. Okay? Now, these are measures. These are one-off quantifications of a thing at a particular point in time. Okay? And that gives you a certain amount of information. Okay? But what if we take these and we turn them into metrics? If we measure them over a period of time at set intervals, and then we can understand how we are improving or regressing on throughput and stability over time. What if we actually weave these metrics together into a single visualization to create indicators, and then we can see how these different metrics are interacting with one another, and if our changes are having a positive impact upon lead time and frequency, one or the other. So a couple of years ago, I thought about applying these measures to production deployments, specifically to create deployment stability and deployment throughput indicators. So with deployment stability, we're looking at deployment failure rate and deployment failure recovery time. And with deployment throughput, we're looking at deployment lead time and deployment interval. Deployment lead time has been referenced multiple times today. What else do people call deployment lead time? Thank you for no one answering. Cycle time. Everyone still calls it cycle time, even though Jez and Dave now actively avoid the term, not least because they gave it multiple different definitions in the same book, bless them. Okay, I shouldn't say that. They might be watching this. Okay, so it's important to measure these things together. Okay, it's not enough to measure one of them. Like I was saying earlier about the 10,000 deploys a day, that's great, but you need other stuff as well. Okay, so your deployment failure rate might only be 1%, but you shouldn't be running around high-fiving yourselves just yet, because if you're operating in extremely volatile market conditions, say you're building a financial exchange, if your unmeasured average deployment failure recovery time is 5 days, then one production instant could finish off your company, right? And likewise, if your deployment lead time, if your time to production is 1 day, that's super duper. But if you only deploy to production every 6 months, then you can almost hear the opportunity costs, sliding away from you. Okay, so deployment stability looks like this. Here is a generic technology value stream. Code is committed, it is built, it goes to production, you know the score. Now, deployment failure rate is the percentage of production deployments that cause a failure. And deployment failure recovery time is the average and variation in the time between the start of a production failure and its remediation. We look at average and variation in order to understand if changes are consistent and sustainable or just a one-off. You might remember in Dan's keynote he talked about flow of value through the system being a sustained situation, not just a one-off. Okay, so that's why we look at normal and that's why we look at average and variation. So for deployment throughput, we look at deployment lead time, that's the average and variation in time between creating an artifact and it being deployed into production. And deployment interval is the average and variation in time between production deployments. Now, don't be fooled by that little arrow there, that one right there, okay? That's where all the time goes, okay? It looks very cute and very small, but that's where you're going to be losing an awful lot of time, okay? So everyone talks about doing value stream mappings, going, yeah, let's look at where our deployment lead time is going. Great. But a lot of time is lost in between builds being actually created. Now, that's all lovely. That's like a proper Steve Smith talk, isn't it? Lots of shiny theory and some colourful pictures that he cooked up at 2 in the morning for you. But wouldn't it be nice if someone had actually gone to the trouble to actually do this for you, right? Then you wouldn't just walk away going, yes, it's another theoretical talk, all right? So that's why for the past 2.5 years I've been slaving away over a hot stove for you in a major UK government department where we have been measuring continuous delivery for 60 teams. So I'm the operations team lead on a private, secure, multi-cloud platform as a service, and we have around 60 teams operating 100 digital services made up of 500 microservices. And obviously they all have different time to market, different stability requirements. My team is responsible for delivery consultancy and also release engineering. So we own the deployment pipeline, and we also help teams to incrementally improve stability and speed. One nice thing about having worked with something like 60 teams is that no one again can ever say to me, well, your things won't work at scale. I get really tired of that word scale. Now, you know, I've nullified that, which is wonderful. Okay, so here is our government department technology value stream. So the way it works is you commit code and you build an artifact. There is then an optional test environment for integration testing. Some teams do end-to-end testing there if I don't catch them fast enough. And there's also a mandatory performance testing environment, and then there's production, and functional testing happens locally. Now, each of the 60 teams have the same technology value stream. There is one fully automated release process, and every team is cross-functional. Every team has developers, testers, business analysts, user experience, user researcher. They don't have operability engineers on the team, but that's because it's a PaaS. That team is centrally based, and teams can do all of their own deployments. Okay? So when we started out on this team, we wanted to help people improve their stability and speed, but we had no idea of how they were faring at the moment. And all of the usual constraints you would think of, like mandatory end-to-end testing, like some kind of crazy change approval system, or too many test environments, those simply weren't a problem. On top of that, which team do you help first when you have so many teams? Do you help the team in London that you have lunch with? Do you help the team in Lincoln stuck on a pig farm that are screaming for help? Do you help the team in Aberdeen trapped in a cupboard, just bashing out code for you? What are they doing? I don't know. They just keep coding. Now, those locations are obviously made up. It was Fishguard, not Aberdeen, but that is a place. But there is a real problem here, okay? And that is, how do you help teams to help themselves before they know they need help? Now, I'll pause for a moment while you think about that. That is a hard problem to solve, okay? The way you can do it is you can measure continuous delivery and show teams their own metrics, show teams their own indicators, and let them improve for themselves, okay? Never compare one team against another. That's a waste of time. It won't work. Show a team itself and how they are improving. Okay, so we decided to create deployment indicators. Our vision of success was easy. I waited until the country went to lunch, and then I wrote a thing that said, everyone will have fewer than 5% failures and recover in less than a day, and deploy to production at least once a fortnight, and it will take them less than a week. Okay? So that's our 4 measures. Okay? Very conservative numbers for this government department on purpose. The idea is we want to split our teams into 2 cohorts. A cohort of teams practicing continuous delivery, which we hypothesize will be a small group, and those are teams that we can learn from and we can amplify their successes. And we think we'll have a larger cohort of teams practicing discontinuous delivery, and those are teams where we want to dampen failures and help them to get better. So, we built an indicator service. This was very, very easy. Who here, when they do deployments, records the deployment result in a database? Not enough people. Start doing that tomorrow, please. It's very, very easy to do it. That information is a gold mine. Okay? So we had a deployment database with 2 years worth of data, and I basically sat on it and wouldn't let anyone ever delete it or archive any data, so I knew I'd need it one day. So we wrote a couple of scripts that sucked the data out. We did some pretty poor median and standard deviation calculations, because my math sucks. And then we fed that information as JSON into a charting engine. And then we shoved the charts onto an internal website where every team can see it. And I got a very senior person in the department to write an email to people saying, this is information about how you are currently doing. We did this with some disks, some scripts, and some charts. Okay, there were no new tools, no new expenses incurred. You really could do this tomorrow, assuming that you have the data, and if you don't, start collecting it tomorrow. Okay, so how were we doing? Well, on deployment stability, we had a minority of teams that were satisfying our vision of success. We had a small number of teams where their deployment failure rate was 0%, and they averaged a deployment failure recovery time of 0 days. So that's good, right? These are teams that we can learn from. But we had a majority of teams that needed our help. They had an average failure rate of 10%, and their deployment failure recovery time was 5 days. Now, obviously, some defects might be a lower priority than others, but that's not. That's a little bit of a worrying average, I think. So, and of that cohort of teams that were in discontinuous delivery, teams with a recent decline in stability were obviously our first port of call, and teams that were improving steadily on stability, those were also teams we wanted to talk to. So this is our first example. This is the Apple's team. This is their deployment stability indicator. So here the x-axis is time. I've picked an arbitrary 6-month period for you. The left y-axis is deployment failure rate as a percentage. The right y-axis is failure recovery time in days. Do we want lines to go up or down? Did someone say up? You're at the wrong conference. Down towards continuous delivery. You want things to be 0, not 9. Okay, so with this team, we can see the deployment failure rate is in blue, and that improved from, let's see, what was it? It was that. They improved from 20% to 0, and their deployment failure recovery time improved from 9 days to 0. So over 6 months, they've made a substantial improvement. So we spent time learning from the team, and we found out that their throughput had improved at the same time. They'd gone from 1 deployment every few days to 4 deployments a day, and at the same time, stability had improved. One of the things that we found about the team was that they were manually creating monitoring dashboards. They were kind of blasé about it. They were like, they just kind of work for us. And then we realized that our other 59 teams didn't have dashboards as good. So we exported the JSON, automated it, put a DSL on top of it, created some default dashboards for our 500 microservices, rolled them out, and within a few days, everyone had dashboards of the same standards, and we saw a marked improvement in time to uncover issues in production. Okay, so on deployment throughput, the results were again surprising. We had a minority of teams that had an average deployment lead time of 1 day and an average deployment interval of 5 days. So they're deploying to production in about a week, and it takes them a day to do it. That's great. But we had a majority of teams that were going to production every 21 days, and it took them 12 days. Okay, so that's, in the context of this government department, that is pretty slow, and we want those teams to do better. One team we found had done 1 production deployment in a year. It had taken them 3 months to do it, from building the artifact to go into production, through 2 test environments. And eventually we found them, and I phoned them up, and they were like, we were wondering when you were going to call us. Bless their cotton socks. So here is a deployment throughput indicator for the bananas team. So here we can see on the left y-axis it's days. The orange line is median deployment lead time, and the green line is median deployment interval. And the lighter lines, I don't really want you to look at, but I want to show them to prove that I'm a little clever, is the standard deviation. Okay? So what we can see here is a gradual decline, okay, a gradual regression. This team was deploying once every 3 days to production, and over 6 months that declined to once a fortnight. Okay? Now we can sit here and we can guess on what the cause of that might be, and that's very easy when you have 60 teams dotted around the country and you're sat in a comfy chair and don't want to travel too far. But there's a very real danger of using any kind of metrics. Well, there are many dangers, but one danger is something called the ludic fallacy, which is in Taleb's book, Anti-Fragile, where people assume they can tell a story from 1 or 2 data points, okay? This is not about telling stories. This is about telling you where to go and find the stories, okay? No other team had this profile. We wanted to talk to them and understand their situation. And it was pretty easy. When we went to see the team, I didn't recognize any of them. And that's because they'd had a lot of turnover in quick succession. The new team members were trying to get to grips with a new digital service, and they were trying to retain a cadence of once every 3 days into production. You just can't do that. So we did a value stream mapping with them. We helped them understand where they were losing some time in their technology value stream, and above all, we offered encouragement, and later on they improved again. Okay, so there's more. So it occurs to me, not only can you take these measures and turn them into indicators, but you can apply them to different aspects of the technology value stream. So in the past, Nicole, Jez and friends have shown that continuous integration is a statistically significant predictor of continuous delivery, to which the continuous delivery community largely went, duh. But it is nice to be able to show someone a piece of paper that says, look, it's written down. You know, stands to reason. If you build things more frequently from master, you have the option to deploy more frequently, right? But what if we measure build stability and build throughput? If a team has build stability and build throughput where we want it to be, then either they can do or will be doing continuous delivery. If a team doesn't have build stability and build throughput where we want it to be, and suddenly they're trying to deploy to production more frequently, that's when it's time to reach for your tin hat and get out your monitoring dashboards. So, for build stability, build failure rate is the percentage of builds that fail, and build failure recovery time is the median and standard deviation in time between the start and end of all of all build failures. And for build throughput, build lead time is the median and standard deviation between committing code to master and producing a artifact. And build interval is the time between building artifacts. And again, that little arrow is where lots of time gets lost. So for builds, we simply applied the continuous integration vision requirements to it. We simply said you had to have a very low build failure rate, a very fast recovery time. You had to have a very fast build lead time. We want less than an hour between committing to master and producing a build. And we wanted you to build at least once a day. So again, pretty conservative, right? So we found a tiny minority of teams were practicing continuous integration, and yes, that included the Apple's team from earlier. They had a build failure rate of 0%, and failure recovery time was less than an hour. But the vast majority of teams were not practicing continuous integration. Build failure rate was up at 19%, and recovery time was 4 hours. One team had an average build failure recovery time of 12 days, which is an awfully long time for the builds to be read. You know, let's go on holiday. It will get better while we're away. Anyway, so here's our example of stability. This is the grapes team. I need to speed up a little bit. So the dark purple line at the bottom shows that the team had very few build failures, but the blue line is of interest. Okay, their average time to resolve a build failure was 10 hours. So again, we can use this information to go and talk with the team, have a good conversation, and we learned that their acceptance test took 10 hours, and when they were under pressure to produce builds, they simply did the build first and ran the acceptance test afterwards, which they viewed as an acceptable risk. But then obviously when it went wrong, they had to go back and do rework and create a new build. So we sent someone into the team to help them improve their acceptance tests and gradually get to a point where they were running tests before actually creating artifacts. Okay, so build throughput. Again, we found a couple of teams averaged a build lead time of 0 hours, and they had a build interval of 2 hours. If you're producing artifacts out of your build stuff every 2 hours, you're doing pretty well. But a majority of teams weren't there yet, and an average build interval of 2 days was not great. So we had plenty of teams that needed help with their builds. This is an example of build throughput. This is the oranges team. Forget the yellow line. That basically shows that their build lead time from master to build was always less than an hour. That's great. But the red line is very interesting, right? You can see an improvement and then a regression back to the mean. So in the first month, they averaged 4 days between builds. Then in a month, they improved to once a day, and then they fell back to once every 4 days. Okay? We spoke with the team. We found that they'd had a significant business event in the spring, and they'd been under pressure to produce as many builds as possible, so they just focused on builds and improving builds. And the moment that the business event passed, they had to go off and do features again, which I'm sure a lot of us can relate to, and the build started to slide again. So with this team, this was really powerful because we actually sent someone to work with them, and whenever they felt a bit down about things, we could say, we know you can do this because you've done it before. Think about the benefits you had at that point in time, and you'll be able to get them back again. Okay, finally, I've decided to go beyond builds and look at trunk-based development as well. So for years, continuous delivery practitioners have found individuals committing code to master more frequently means you can build more frequently, means you can deploy more frequently. I don't understand why that's so controversial. Jez still says to me it's the most controversial thing he's ever spoken about, and he delights being parachuted into countries, literally parachuted in, to talk about trunk-based development before Thoughtworks or Dora pull him out. You know, he'll phone me, he's like, I'm behind enemy lines, they're branching. What shall I do? I tell them to stop. It doesn't work. So Jez and Nicole have found that trunk-based development and continuous integration together are a statistically significant predictor of continuous delivery. I believe we'll find some point soon that trunk-based development itself is a statistically significant predictor of continuous integration. So we can't really do a code stability indicator because version control systems won't surface that information to me very easily. But you can do code throughput, right? You can look at mainline commit lead time, the time between you commit something to a branch and then subsequently merge it to master. If you go straight to master, then A, you get a score of 0, which is good, and B, you're my friend. And mainline commit interval is the average time and variation between commits to master. So we applied our vision again of 0 hours between branch and master, and you should be going to master at least once a day. Obviously, that should be smaller if you have a larger team, because everyone has to commit to master for continuous integration to happen. Okay, so when we looked at this, the numbers were pretty shocking. So we found that the teams that were practicing continuous integration were committing to master every 2 hours. Yeah, that's pretty good. But the average of the cohort practicing discontinuous delivery was 5 days. Okay, so those teams are teams that we need to help, especially those teams that are going in the wrong direction and are perhaps experimenting with changes that will worsen their situation. So here's our final example. This is the Pears team. Never eat another pear after this. So this team wanted the release engineering team, my team, to allow them to build branches on the build server. I will be nice. They believed that it would help improve their build throughput as well as build stability. I patiently explained that it would not help build throughput and there are other ways to help build stability. Their request was declined. They were a little sad. We looked at their code throughput together and we found out that they had a pretty bad problem. So the dark blue line here shows their average lead time from branch to master worsened from 0 hours to 34 hours in 6 months. Okay? Now that doesn't look so great on that graph, but that's not my fault. I know what I'm doing with Google spreadsheets, thank you. It's because the y-axis is enormous, right? Over 6 months, their average time to commit to master worsened from 4 days to 27 days. Okay, so they're committing to master once a month. Now clearly this team didn't get the memo about only using GitHub Flow or trunk-based development. I went to speak with the team lead, who turned out to be an extremely nice person, and it turned out that they had basically been asked to make sweeping architectural changes while continuing to deliver features. And branching was the only solution they knew to do that. So we said, have you tried feature toggles? They said, can you do feature toggles in government? I said yes, and no one I said yes, no one's ever told me off, so I just keep saying it to people until I'm told off. And now there are feature toggles everywhere, which is wonderful. And this team especially benefited from it. Their build lead time came down after this, their build interval came down, but they've also had operability benefits. They had a situation where a third-party supplier API stopped working in production, and before anyone could get out the full-on panic mode, they simply said, oh, let's turn off that toggle and just return some dummy data for that supplier until they can sort themselves out. So let's wrap up a little bit. So I've shared with you the indicators and some stories from a 3-year, 60-team program where continuous delivery has gained real traction. Measuring continuous delivery did not tell us what decisions to make, but it did tell us where to go to find the stories that will give us that information of a high value, okay? Automating monitoring dashboards, improving feature toggles, just knowing who to help, all came about because of our ability to measure throughput and stability. This approach will work with 1 team, 20 teams, or 60 teams, okay? So, this is the book. There's a URL there. It's 50% off today. If you come and find me later on, I can probably be talked into lowering that again. Because it's not really, I'm not fussed about royalties or whatever. I'm fussed about just sharing this information. It would be a bunch of blog posts anyway. Who here wants to incrementally and iteratively adopt continuous delivery? Yeah, everybody knows that, right? The Improvement Kata is a perfect fit for continuous delivery. I'm not going to stop. Don't show me that. Honestly, stop. I'm never going to stop. I'm going to stay here. Who here, I can't believe I did that, good grief, it's my own conference. Who here wants a way to understand progress and make better decisions while adopting continuous delivery? We all want that, right? Continuous delivery is really, really difficult, okay? And often it's because you simply have a fog around you, you don't know what you're doing, okay? Measuring throughput and stability as indicators, not just as measures, continuously measuring stuff, will give you really powerful insights into your continuous delivery journey. Thank you very much. I can do questions afterwards. We are out of time. It's been emotional.